Hey everyone, welcome to the channel. In this video, we will be looking at one of the advanced algorithms, which is Z algorithm. So let's get started. So what is Z algorithm? Z algorithm is a linear time string matching algorithm and it is used to find all the occurrence of a pattern in a string. So if given a text and asked to find the pattern in the text, we use Z algorithm. So this provides the index at which the pattern is present. So for this we need to create a Z array. We'll see what Z array is, and the values stored in this Z array are known as Z values. So let's take a look at this example. Pattern AAD is given and we need to find this in the given text. So we will be concatenating the strings using a dollar symbol and initialize the values to 0 in the array. Note that the first value of the Z array is always 0. Now we'll move to index 1. Compare index 1 with index 0. They both are equal. So we'll compare index 1 with 2. They both are not equal. So the Z value of A, which is at index 1, is 1. Now we'll move to index 2. In comparing index 2 with index 0, they are not equal. So the Z value is 0. And moving to index 3, they are not equal. It is dollar symbol and A. So the value is 0. Moving to index 4 and index 0 are equal. Now we'll move index plus 1, which is we'll be comparing index 1 with index 5. They are equal. Now moving to index 2 and 6, they are not equal. So the Z value of index 4 is 2. Similarly, we'll be comparing every index. So comparing index 5 with index 0, they are equal, and index 6 with index 1, they are not equal. So the Z value of index 5 is 1. Index 6 and index 0 are not equal, so the Z value of index 6 is 0. Similarly, 7 is also 0. Now comparing 8th index with 0th index, they are equal. We'll be moving indices plus 1, which is comparing 9th index with 1st index. They are not equal, so the Z value of index 8 will be 1. Now moving to the index 9, it is not equal with index 0. D and A, they are not equal, so the value is 0. And moving to index 10, the 10th index and 0th index are equal. Now we'll be moving indexes plus 1. 11th index and 1st index are also equal, and similarly say 12th index and 2nd index are also equal, so the Z value of 10th index is 3. Similarly, the value of 11th index is 1 and 12th index is 0. Now to find the pattern in the text, we will be traversing through the Z array and we'll be finding the value which is equal to the length of the pattern. Here it is found at 10th index. So 10th index minus the length of the pattern, which is 3, minus 1. So the pattern is present at index 6. So the time complexity is O of m plus n, which is we'll be traversing through the Z array of length m plus n, which is m is the length of the pattern and n is the length of the text, as well as the space is also equal to O of m plus n. Now let's take a look at the pseudocode. Function Z algorithm is declared. Text and pattern are used as parameters. Concatenated string is the pattern plus dollar symbol plus text, and Z is an array of length concatenated string. We'll take a look at this example. As you can see, dollar symbol is used to connect pattern and text. Now initialize the array with zeros. Now we have variables L and R, both are equal to 0. Now we can see a loop, for loop, from which I is equal to 1 to the length of concatenated string minus 1. So I is equal to 1, L is equal to 0, and R is equal to 0. If we see the loop, if loop, it says I is greater than R. So here I is greater than R. So L is equal to R is equal to I, which is I is equal to 1, L is equal to 1, and R is equal to 1. So going to the while loop, R is less than the length, and concatenated string of R minus L, which is 1 minus 1, which is starting from index 0 and the next index. We are comparing both of the indices and we can see both are equal, so R is incremented by 1, so R is equal to 2. Now iterating through the while loop, index 1 and index 2, they are both are not equal, so we'll be coming out of the while loop. z of I, which is z of 1, is equal to r minus l, which is 2 minus 1. So the value is 1. Now r is decremented by 1, so r value is equal to 1. Now I is equal to 2. So I is equal to 2, L is equal to 1, and R is equal to 1, which is I is greater than R. So we have L is equal to R is equal to I, which is I is equal to 2, L is equal to 2, and R is equal to 2. Now we'll be iterating through the while loop. Now we'll be comparing second index with the 0th index. They both are not equal, so we'll be coming out of the loop. Z of 2 is equal to R minus L, which is 2 minus 2 is equal to 0. Now r is equal to r minus 1, so value of r is 1. Now I has been incremented, so I value is 3. Now if we check the if loop, which is I is greater than r, which is 3 is greater than 1, so we'll be going into the loop. L is equal to r is equal to I, which is I is equal to 3, L is equal to 3, and r is equal to 3. And they both are not equal, so the value is 0. R is decremented, so R is equal to 2. Now I has been incremented, so I is equal to 4, R is equal to 2, and L is equal to 3. As I is greater than R, we will be getting into if loop, which is L is equal to R is equal to I. So R is equal to 4, I is equal to 4. Now we'll iterate through the while loop. R is less than the length, and we'll check that index and the first index, they both are same, equal, so r value has been incremented, so r value is 5. Again we'll iterate through the while loop. So now we'll move one index further and we'll check both are a, so r value is further incremented. Now r value is 6, and again we'll move one step forward, and D and B, they both are not equal, so we'll come out of the loop. Z of I, which is Z of 4, is equal to r value is 6, 6 minus 4, which is equal to 2. Now I is incremented, so I is equal to 5, L is equal to 4, and R is equal to 2. So I is greater than R, so we'll go into if loop. L is equal to R is equal to I, so L is equal to 5, R is equal to 5, and I is equal to 5. Now if we iterate through the while loop, so we'll be checking that index and the first index, they both are equal, and the next two indices are not equal, so we'll come out of the loop. Z of I is equal to 6 minus 5, which is equal to 1, and value of R is decremented, so R value is 5. So now I has been increased, so I is equal to 6, R is equal to 5, and L is equal to 5. So I is greater than R, we'll go into the loop. L is equal to R is equal to I. So now we'll go into the while loop. We'll check that index and the first index. So both are not equal. We'll come out of the while loop. Z of I is equal to R minus L, which is 6 minus 6. So that Z value is 0, and R has been decremented. So R is 5 now. Now I has been increased. I is 7, R is 5, and L is 6. We can see I is greater than R, so we'll get into the if loop. L is equal to R is equal to I, so all the values of L, R, and I is equal to 7. We'll go into while loop. We'll check C and the first index, which is A. They both are not equal, so we'll come out of the loop. And Z of I is equal to R minus L, which is 7 minus 7, which is equal to 0, and R has been decremented. Now value of I is 8, so value of R is 6, and L value is 7. So I is greater than R, so we'll get into the if loop. L is equal to R is equal to I, so we got R is equal to 8, L is equal to 8, and I is equal to 8. We'll get into the while loop, and we'll check that index and the first index, which is D and A. They both are not equal, so we'll come out of the loop. Z of I is equal to R minus L, which is 8 minus 8, which is equal to 0, and R is decremented, so R value is 7 now. Now I is increased, I value is 9, R value is 7, and L value is 8. Again I is greater than R, so we'll come inside the loop. L is equal to R is equal to I, so R is equal to 9, L is equal to 9, and I is equal to 9. We'll get inside the while loop. We'll check that index and the first index, they both are equal, so R has been increased by 1. Now the value of R is 10. Now again it will iterate through the while loop. Now the indices are increased by 1. Again they both are equal, so the value of r is increased by 1. Now the value of r is 11. Again it is increased by 1 and they both are equal, so the value of r has been increased to 12. Now we'll come out of the loop. Z of I is equal to r minus l, which is 12 minus 9, so the value of that z value is 3 and the value of r is decremented. Now value of I is increased, I is 10 and r value is 11, so I is less than 11, so we'll get into the else part. So in else part we have k variable, k is I minus l, which is 10 minus 9, so we get k value as 1. And in if loop we have z of k and r minus I plus 1, so we'll get r minus I plus 1 value to be 11 minus 10 plus 1, so the value is 2. And z of k, which is z of 1 value, is 1, which is less than 2, so we'll get into the if part. And so z of 10 value will be 1. Now the value of I is 11, r is also 11, so l is 9, so we'll get into the else part. K is equal to I minus l, which is 11 minus 9, so the value of k is 2. So z of k, which is z of 2 value, is 0 and r minus I plus 1 is equal to 1. So we can say z of k is less than r minus I plus 1. So z of I is equal to z of k, which is z of 11 is equal to z of 2, which is equal to 0. And if you want the implementation of this code in C, C++, Python, and if you want time complexities, you can see it in the description box. Link is shared.